In this video, we're going to be talking about using the zero factor property, or zero product property, as I've also heard it called, to solve equations involving polynomials. So what this property says is that if you have two factors or more, so two things or more being multiplied together, and they're equal to zero, then one of the two things has to be zero. Right? So if I had, let's just do x plus 2 times x minus 3. So this whole quantity in the parentheses, this is a factor because it is being multiplied by something else. So I have two things being multiplied equaling 0. And what that the property says is that either this set here has to be 0 or this set here has to be 0, right? Which makes sense. So 0 times this quantity is going to equal 0, or 0 times this quantity is going to equal 0. So if I have two factors equaling 0 when they're multiplied together, then either that first quantity has to equal 0, which would make sense. If I solve this for x, x has to be negative 2. Then when I plug it back in, I would have negative 2 plus 2, which would give me 0, and 0 times anything is 0. So x could be negative 2, or I set the other factor equal to 0, and I solve for x. So add 3 to both sides, and x would be 3, which again makes sense. If I plugged in 3 minus 3, granted we don't do them at the same time, but if I plugged in 3 minus 3 into the other parenthesis, I would get 0, and 0 times anything would be 0. So I'm going to end up with a true statement here. So the method that we use to solve polynomial equations is first we have to make sure everything's on one side and it's equal to 0. So this property only works because of the 0. It's 0 times anything that makes it 0. So it has to be set equal to 0. Then we factor the polynomial that we have. And once they are factors, so things being multiplied, then either one factor or the other factor, or if there's more factors, one of them has to be 0 to multiply and equal 0. So each factor has to be set equal to 0, and we solve to find the variable. So let's go ahead and try that. This first example here is already set equal to 0, so step 1 is done. Step 2 is factor. I notice there are 1, 2, 3 terms. So I want factors of negative 16 that are going to add to negative 6. Noticing that my front coefficient here is 1, so it's just factors of negative 16 that will add to negative 6. So maybe 8 and 2. If I put the negative with the 8, I'll have negative 8 times a positive 2 gives me the negative 16, and negative 8 plus 2 gives me the negative 6 in the middle. And since that front coefficient is 1, I can go straight into x minus 8 times x plus 2, still equaling 0. Now that these are factors, things being multiplied, then that means that this factor has to be 0, because then 0 times this would give me 0, or this factor has to be 0, because then 0 times that quantity would also give me 0. So I set each one equal to 0 to figure out what x needs to be to make those factors 0. So over here I add 8, so x could be 8. Over here I would subtract 2, so x would be negative 2. So x could be negative 2, or x could be positive 8. There's two solutions here. And you might notice that's the opposite sign of what was inside, right? Positive 8 minus 8 would give me 0. Negative 2 plus 2 would give me 0. We're going to see that kind of pattern throughout. So now, let's look at another one where it's not set equal to 0. So in this case, I have some multiplication on that side, some multiplication over here, but there's no 0. So I have to start by multiplying all this out. So x times x will give me x squared. Negative 8 times x is negative 8x. And then x times 7 will give me positive 7x. And lastly, negative 8 times a positive 7 is negative 56. And again, you could box that out or FOIL that out, whatever multiplication method you like. Then on the right here, I'm going to distribute that 2. 2 times x is 2x. 2 times a negative 1 is negative 2. And I need to get everything on one side so that this is equal to 0. So I'm going to start by subtracting 2x. Oops, that's too big. Let's see if this is better. Minus 2x. And I'm going to do it with this like term. I'm going to add 2. Do it with this like term. And look at what's left. So I'm going to add all my like terms on both sides. So I only have 1x squared. That's going to stay x squared. And I have negative 10x with the negative 8, negative 2, so negative 10. But then plus 7x. So it's going to end up at negative 3x. And then a negative 56 plus 2 is going to get me negative 54. And these are 0, so the right-hand side is 0. So everything's on one side, now I factor. Again, I see 3 terms, so I'm looking for factors of negative 54 that are going to add up to my middle term, which is negative 3. I'm thinking 9 and 6 are 3 apart. One of them needs to be negative to multiply to a negative, and since my middle term is negative, it needs to be the bigger number. So negative 9 times 6 is negative 54. Negative 9 plus 6 is negative 3. And the front coefficient here was 1. I'm going to go straight into my parentheses. And x times x gives me x squared minus 9 and plus 6 were the factors I found. So now I have it factored. I set it each factor equal to 0. So that means that x could be positive 9. We add 9 to both sides. Or x could be negative 6. We subtract 6 from both sides. And those are our 2 solutions. Alright. This last one here on the left. So right away I see a fraction, and I really don't want to have to deal with that fraction. So what I'm going to do is I'm going to clear out my fractions by multiplying both sides of my equation by the denominator of that fraction. So this has a denominator of 2, and multiply both sides of my equation by 2. Remember, whatever I do to one side, I have to do the same thing to the other side to keep it equal. On the left, I'm going to distribute that 2 to both terms. So again, I have to multiply everything by 2 to clear out that fraction. So 2 times 2x squared is 4x squared. The 2's will divide out in that middle term, so I'd be left with just positive 5x. That's the whole reason we multiplied by 2. And that will equal 3 times 2 is 6. Now I need to get everything on one side. So 4x squared plus 5x is going to stay the same. And I have to subtract 6 from both sides to get it on the left-hand side. Oops, my marker froze for a second. And now that will equal 0. So that 0 is so important. It's 0 times anything that makes 0, which is what makes the property work. Now, I have all my terms on one side. I can factor. I see 1, 2, 3 terms, and the front coefficient is not 1. So I have to be careful with that. Let me get a different color here. So now when I do this, I have to think about a times c. So 4 times a negative 6 is negative 24. So I'm looking for factors of negative 24 that add up to positive 5. So I'm thinking 8 and 3. And if I want this to be positive 5, but this is negative 24, then I have to add the negative to the 3. So I need one negative to multiply to give me a negative, but it has to add to a positive 5. So now that I've got my factors, I pay attention that this front coefficient is not 1, so I'm going to rewrite it as 4x squared, so the first one stays the same, and instead of 5x, I'm going to write 8x minus 3x. Right? So 5 is the same thing as 8 minus 3. And then the last one stays the same. Now I've got 4 terms, and we factor by grouping. I'll look at the first 2, and I'm going to take out a 4x, the GCF for the first 2 terms. If I divide out a 4x, I'd be left with x, and then divide out a 4x here, I'd be left with positive 2. Then I look at the second 2 terms. I take out the GCF of these 2, so a negative 3. If I divide out a negative 3, I'd be left with positive x, and negative 6 divided by negative 3 is positive 2. Not quite done. I notice these are in common now. I have a binomial in common. So I factor out x plus 2. When I divide those out, I'm left with 4x minus 3. Still equal to 0. Alright, so now I have it factored. I have to set each factor equal to 0. So x plus 2 equals 0, or 4x minus 3 equals 0. I have to solve each one for x. Over here it's nice, I just have to subtract 2 from both sides. So x could be negative 2. Or over here I have to add 3 first. So 4x equals 3, and then divide by 4. So x could be 3/4. And those are my 2 solutions. So again, the steps: get everything on one side, factor using whatever the proper factoring method is for the number of terms, and then set each factor equal to 0 and solve for x. Try the ones on the right. Alright, we're over here now with 3x squared plus 5x minus 2 equals 0. And we want to start by factoring. Since everything's already on one side set equal to 0. I notice here that the front coefficient is not 1 in this 3 terms here. So I need to take a times c which is 3 times negative 2, so negative 6. I want factors of negative 6 that will add up to positive 5. So I'm thinking 6 and 1, and one of them has to be negative, so I'm going to put the negative with the 1, so I end up with a positive 5 in the middle. Now, since that front coefficient is not 1, we have to break up that middle term into the two factors we found of positive 6x minus x, right? 6 minus 1 would give me the positive 5. The last term stays the same. Now I have 4 terms, so I'm going to factor by grouping. Group my first 2, group my last 2, take out the GCF of the first 2. So they both have a 3 and an x in common. When I take that out, I am left with the 3's divide out, one of the x's, I still have 1x. 6 divided by 3 is positive 2, and the x's divide out. On the right, I notice that they both have a negative, so I'm going to take out a negative 1. That changes my negative x to positive x, and my negative 2 to positive 2. And then, if I did it right, these two binomials should match, and they do. So I'm going to pull that out as my GCF. And what's left when I pull that out, I have a 3x and minus 1. Oops, my screen froze a little bit there, so let me undo that. So 3x minus 1, still equal to 0. Now that it's completely factored, I set each factor equal to 0. So x plus 2 equals 0, which when I solve it means x equals 2, or sorry, negative 2. And then same thing with that 3x minus 1, I'll set equal to 0, add 1 to both sides, divide by 3. So x equals a positive 1/3. And those are my two solutions. Let's continue on with the next one. And remember, we can always plug these in and check them to make sure they end up with true statements. If something is a solution, I should be able to plug it in and get a true, it should equal, right? True statement. Alright, here I have x cubed equals x squared plus 6x. In general, we want to keep our leading term, so our highest degree, positive. So I'm actually going to move my x squared and my 6x over to the left-hand side. So I'm going to leave this one alone and subtract that x squared over and subtract the 6x over to set it equal to 0. Always start with your GCF, so they all have an x in common. So I'm going to go ahead and take that out first. So I'll pull out my GCF. I'm left with x squared minus x minus 6 equaling to 0. And then I factor what's left, so it's a trinomial. I notice that the c term is negative 6, and I want it to add up to negative 1. So I'm thinking 2 and 3 will multiply to 6. One of them has to be negative to get that negative in there. And I want the negative to go with the bigger number, so I end up with negative 1 when I add them. Since my front coefficient here is 1, I can go straight into my two sets of parentheses. And x times x will give me x squared. I found a positive 2 and a negative 3 for my factors of 6 anyway. Alright, so now it's totally factored. And I notice here this is x times x plus 2 times x minus 3. Each one of these separated by times is a factor. I have to set each one equal to 0, including this x. So a lot of times that one gets forgotten. If x itself was 0, I'd have 0 times all this stuff, and it would equal 0. So that, right away, is one solution. from this x. Then I set x plus 2 equal to 0, which means x could be negative 2. That's another solution. Oops, sorry about that. The system crashed for a second. So lastly here, we have x minus 3 could be 0, which means x could equal 3. So I have 3 solutions, and that's going to be true in general. If I have the degree of this polynomial is degree 3, I'm generally going to end up with 3 solutions. If the degree is second, so squared here, I'm going to end up with 2 solutions. And that's just a general rule of thumb. Sometimes we have what we call repeated solutions, so you might not get 3 distinct answers, but in general you will. So that's another good check for yourself to see if something is factored completely. Alright, now let's look at this next one. Same idea. My highest degree is x cubed, so I'm going to move everything over to join that x cubed on the left hand side. So I get my polynomial set equal to 0. So I would subtract 4x to move that over, and subtract 28 to move that over, and then it would be equal to 0. Now I don't have a trinomial, I have 4 terms. So if I have 4 terms, I'm going to go right into my grouping. Looking at the first 2, I want to pull out a GCF. So the GCF that the x cubed and 7x squared have in common is an x squared. What's left when I take that out? X cubed divided by x squared is just x. 7x squared divided by x squared is going to be positive 7. And then I notice these are both negative, so I'm definitely going to take out a negative here. And they both have a 4 in common. When I divide out a 4, I'd be left with x plus 7, right? Negative 28 divided by negative 4 will give me a positive 7. Then I see I have a GCF of x plus 7. We both have one. Pull that out. And I'm left with an x squared minus 4. And I'm not quite done. So a lot of people want to stop here. But I have to go back and check after I'm done factoring, see if there's anything else to factor. Right here I have a difference of squares. I need to keep going. Difference of squares is going to factor into conjugates. So x times x would give me that x squared. I need a plus and a minus. And then 2 times 2 would give me 4. So then each one of these has to get set equal to 0. I'm going to do it up here. X plus 7 equals 0, which I'll subtract 7 from both sides. So x could be negative 7. Then x plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. And then x plus 2 equals 0. So subtract 2, or sorry, minus 2. Let's undo that for a second. Too many pluses there. Minus 2 equals 0. So I add 2 to both sides, and x could be positive 2. Again, notice I had degree 3 of this polynomial, and I ended up with 3 different solutions. Alright, the last one here. This one has a lot of stuff going on, so we need to make sure that we're taking care of all of it. So first thing, I need to get rid of these parentheses. I'm going to distribute. 2 times x squared and 2 times 5 gives me positive 10. Don't lose this other 10 I already had. Then I'm going to distribute on this side as well. Negative 2 times x squared. And a negative 2 times 10x is negative 20x. And I still had this minus 5. That was already there. In general, we want to keep our highest degree positive, so I'm going to move everything over to the left, because this x squared is already positive over there. So I'm going to add 2x squared to both sides. I'm going to add 20x to both sides. I'm not adding it to this 10. They're not like. I'm just putting it over here on the left. And then adding 5 to both sides. So these are all 0. And on the right hand side, I now have 4x squared, a positive 20x, and then 10 plus 5 is 25, equaling 0, because this was all 0 over here. Alright, I look at this and I see, these are going to be some big numbers if I try to multiply it out and find factors. But I do notice a little shortcut here. This is a perfect square, and this is a perfect square, right? This is 2x is being squared. 2x times 2x will give me 4x squared. This is 5 squared. If I multiply these two things together, I would get 10x. And then if I double it, I would get 20x. So this is a perfect square trinomial. I can factor it into a binomial squared, which will be 2x plus 5, that whole quantity squared. Or 2x plus 5 times 2x plus 5 means the same thing. That was one of those shortcuts, right? If you didn't want to do the shortcut, you could just multiply 4 times 25, get 100. You would need factors that are going to add up to 20, which I'm thinking 10 and 10. But then you'd have to rewrite that middle term and use grouping versus this shortcut, factoring a perfect square trinomial into a binomial squared was much faster. But both ways work, right? So really, I just have this one factor that's repeated. It's the same factor times itself. So I only have to solve it once. 2x plus 5 equals 0. I would subtract 5 from both sides and then divide by 2. And x equals negative 5/2. And if I did it again, I would get the exact same answer. So I don't need to do it twice. Alright, so that was one of the ones I actually talked about with a repeated solution. So in general, if the highest degree is an x squared, you should have 2 solutions. But this one had a repeated solution, so there was just one.